In this video, we're going to be looking at network protocols. We're going to look at a variety of different things, including what a protocol is, the purpose of specific protocols, and how data is sent and received between multiple devices. The definition of a protocol is a set of rules for exchanging data between devices. We can also word this as an algorithm for exchanging data between devices. The key idea is that we want to be able to send data from one machine and receive it into another. Don't be misled by the pictures. We could be sending data from a computer to a server, a computer to a mobile phone, a server to a mobile phone, and so on. The protocols remain the same. Protocols are layered into 4 different layers. They are the application, transport, internet, and network layer. I'm going to go through what each of these different layers does and their purpose. We're going to imagine that we are sending data from one device to another. The application layer defines what type of data is going to be sent. Different protocols are used for communicating different types of data. HTTP is used for sending and receiving of web pages. FTP is used for sending and receiving of files. DHCP is a protocol which is used when connecting to a network to allocate network information to a device, including an IP address. And the final one that we're going to look at is DNS, which takes a URL of a web page, you might also know this as a web page link, and converts it into an IP address. This allows the device to request a web page from that address. There are 3 other protocols that I will discuss which are relevant to the sending and receiving of emails. POP and IMAP perform very similar functions. They are both designed to exchange mail between a server and a client device which wants to view or edit the mail. POP works by taking a copy of all mail on a server and putting it onto the client device. This has the disadvantage that it deletes all of the email from the server when it has downloaded the emails. So you can only use POP on one registered device. IMAP is a more modern protocol which allows you to edit mail which is on a server. This allows you to use an email account across multiple devices. And the final one, SMTP, is used for exchanging emails between different servers. So imagine that you're sending an email from your school account to a home account. Those accounts are located on different servers. SMTP exchanges the mail between those servers. In this example, we're going to look at how we could use FTP to send an image file. So on the top layer at the application, we've selected our data that we're going to send, and we've identified that it is a file we want to send. The transport layer will operate on that data next. The protocol which we use is called TCP. Its job is to take our original file, break it down into packets. The reason that we do this is because if we send a file in one lump go, then that means that we're using all of the bandwidth on a connection. This prevents other users from being able to use that connection. We have to share the bandwidth. And by sending the data as packets, that helps us to be able to share it better. Another thing that the transport layer does is it will add sequence numbers to each of the packets. This is so that when the data is received at the receiving end, the data can be reassembled back into an order. We also add something called a checksum, which is a mathematical function which is performed on the packet and can be performed at the other end. The results can be compared, and that will prove whether or not a packet of information has been corrupted during transmission. When all of this information has been added to the individual packets, we move on to the internet layer. On the sending side, the IP protocol or internet protocol will add 2 addresses to the packet, amongst other data. They specify where the data is coming from and where the data will be going to. This is done through the form of an IP address. It's a unique number which identifies each computer. The network layer is quite simply the means by which data can enter and leave a device. 2 methods that you may already know about are Wi-Fi and Ethernet. Wi-Fi is a wireless connection between a device and a network, and Ethernet is a wired connection between a device and a network. This is the entry and exit point for any data entering a device, and it doesn't matter which one is used. When data is received by another device, first of all, it will look at the IP address of where the data is heading to. If this matches the device that it is currently on, then it will accept the packet and retain it, and feed it up towards the transport layer. If not, it will forward that packet onto another device which can point the packet in the right direction and get it closer to its final destination. The transport layer, again on a receiving side, has a variety of different roles. Packets may arrive in a different order to which they were sent. This is because packets can take different routes around networks. When they arrive, they are checked to check that they are not corrupt. If we look at packet 4 here, we can see that something's gone wrong, and the checksum doesn't quite match. To get around this, what happens is the TCP protocol will generate something called an acknowledgement. This acknowledgement is a way of sending a message back to the initial sending machine and saying thank you for sending me packets 1, 2, 3, 5 and 6. I've got them. That acknowledgement is then sent back to the sending device. The sending device will only wait for so long to receive these acknowledgements, and if it doesn't receive them within a certain time frame, it will automatically send the packets again. So in this case, on the receiving side, because it has not acknowledged packet 4, it will discard what it has and wait for a copy to be sent. When that's received and the checksum matches, an acknowledgement will be sent back to the sending side for that device. When all packets are successfully received, they will be reassembled into the original file. This then allows for the application layer to present the data to the user. The transmission has now been completed. It's really important that you understand that when we're sending and receiving data, it is not a case of being able to simply send data out of one device and then it enters the receiving device immediately. What actually happens is the data will go through that process and be exchanged between many routers on different networks. The job of a router is to move packets between one network and another. I've got 2 routers here. In actual fact, when exchanging data, it may travel through many routers. So don't always think that it's just 2 routers that any data has to travel between. It could be many. The reason that the routers do not use the transport or application layers is because they are not interested in how many packets need to be sent or what the data is. Their job is to receive packets at the network layer, inspect where they are from and when they are going at the internet layer, and send them on to the next device. And this process repeats until the packets reach their final destination and can be presented to their user. Now you might be thinking, why do we split protocols up into different layers? Let's imagine that we have a protocol which is used for sending and receiving files, which incorporates all of those different functions that I've just talked about. The issue with this, compared to having protocols which are layered, is that when we use those protocols, if any changes need to be made to certain layers, we have to change the whole protocol. By layering them, we can quite simply choose which protocols are used in different layers, and they can feed the data to different layers in the protocol stack. We could imagine using HTTP here, which handles web pages. We would then break the data down, attach IP addresses, and send it out in exactly the same way as we have just used the file transfer protocol. So whenever we think about protocols, we need to think about the 4 layers which can be used to do so.